Yeah, Malik, we've got your file over here.
Okay. Okay.
So let's go through this. Siddharth, you
Sure.
managed to do the exercise? Hello, Siddharth.
Yeah, Karan, I didn't get time to do that.
All right. No problem. Try and exercise, do the exercises, else you'll start forgetting very soon. All right, so let's have a look. So yeah, Malik, can you take us through this? Is this your sheet?
Yeah.
This is your sheet, right? All
Yes.
right. So
Oh,
telecom.
no, this is not mine. No, this is not mine.
Okay, let me just close this.
I think it's, yeah. This is mine.
Okay, this is your sheet. All right. So this is your model on the original
Yes.
variables.
Yes, exactly.
All right. This is original variables. Training or validation? This is training or validation?
I think you are referring to other sheet right there.
Yeah.
This is Siddharth's sheet, I guess.
Okay, this is not your sheet. This your sheet? Wait a minute. I'll just open your mail itself.
Okay.
Look. All right. Here's your mail. So. Yeah, so let's have a look at telecom factor training model, telecom factor validation. Right, so I'm opening your validation sheet
Yeah.
over here, Malik. Let's have a look.
Okay.
Alright, yeah, so here you've
Yeah.
validated the model. Right,
Yeah.
cumulative goods you've got over here, cumulative bads you've got over here, and where is the separation? Right, here is the separation. So you're getting
Okay,
a
separation.
KS separation of 43 on validation, right?
Yes.
And first
In
decile
the case of
27.
variables,
Pardon?
in the case of variables, that is a model built on the variables, case separation is both for the training model and validation model.
Okay. Alright, let's have a look. So this is your validation model for factors. Are you sure? Yeah, this is for factors. Okay. And your case was
No, this is not
43.
for factors. This is on the variables.
So this is written telecom factor validation mod underscore F.
Yes.
So this is the full variable model or the factor model?
This is the variable model. One more Excel sheet is there for a factor model.
Let me have a look. Alright, the other sheet's name is telecom factor valid mod F.
There are four sheets.
The names are the same for.
Mod F, yeah, that is a factor model.
Okay, let's have a look.
No, mod F.
Yeah.
Yes.
So here your case is 46 for factor model, you're saying. All right, and for the training model, it's 43 for the variable model. So which one is performing better? So factors is performing better for you? Yeah, Malik. Malik.
Karan, you there?
Yes. Which model is performing better? Yeah, Malik. Can you hear me?
Karan?
Yes, Siddharth. Can you hear me? Hello. Hello. Yeah, Malik, can you hear me now? Yeah, Malik, Siddharth, am I audible? Yeah, Malik, Siddharth, am I audible now? Hello.
Yes, sir. Now you are audible.
Okay, perfect. So I was asking that which particular model is performing better for you, full
Yes,
variable
yes,
model
sir.
or validation model, or sorry, factor model?
Okay.
Yeah, so which model is performing better, all variable or factors only?
Full variable is performing better, but full variable validation model is
So you're saying, no, Malik, I see your factors is performing
mm,
better, right?
all variable.
No, your factors model is giving you better case.
Yes, that is 46, right?
Yeah, so why will you say that full variable
Yeah,
model is
but
performing
with
better?
respect to ROC, full variable model is performing better, sir.
ROC on training or validation?
Because of ROC value. In the case of validation,
Malik, you calculated ROC on
around
training or validation?
0.852. Yes, sir. I have included ROC value in the mail itself, sir.
Malik, have you calculated ROC on training or validation?
Yes. Both, sir.
How did you do it for so what is your ROC on validation factors and what is your ROC on validation full variables?
Validation. Full variable is 0.852
That's training or
and
validation,
factor
Malik?
is 0.824.
Training or validation, Malik?
Validation, sir.
How have you calculated validation ROC?
Validation.
How have you calculated validation ROC?
Uh, I generated using SAS output itself.
But SAS output will give you training ROC alone, not
I
validation.
no, I can um,
Right, Malik?
yes, I guess.
Malik,
Actually,
that proc
yes, yes.
logistic
Actually, I
output,
changed the data set to a validation set, and then arrived at
that proc logistic you run on
yes,
training.
yes.
So that is the training ROC, not the validation ROC, right?
Yes,
Right. So what I'm going to do is I'm going to paste this
yes,
into
exactly.
SPSS
Yeah,
and
actually, I changed the data set. Mhm.
pardon.
Okay, okay.
Yeah, Malik,
Yes, yes, I did a mistake, sir.
explain to me what have you done. So there is some confusion.
Yeah, actually, generally we build a model using training data set, right?
Yes.
And we get the ROC value for the training data set.
Yeah,
So
but
similarly, I did the Proc logistic model on the validation data set also. That means directly I plugged in the validation data set.
no.
And in the SAS output, I got the, yeah, that's what I did mistake in that, which is not supposed
So
to be
Malik, you
right.
created two different models, one for training dataset and one for validation dataset, is it?
Yes.
But that's not what you're supposed to do, Malik.
No, only for ROC I did that. For calculating, yeah, yeah. Yeah, only for calculating ROC value I did like that. And rest of things, remains same.
For ROC, you can go to SPSS and generate the ROC, right?
Yes, sir.
Right, I go over here and I get the ROC value out. Right, so I've just copied your data set, your actual variable and the predicted variable. So your ROC is coming 0.805 over here, right? And this is on your
Yeah.
validation lifts factor model. Let's
Yeah.
have a look at your validation or your full model.
Validation with factor is coming to 0.785.
Right? Let's look at your full variable model.
Okay.
If I look over here, right? So Malik, your factor validation ROC is 0.805 and your full variable model ROC is 0.798,
Yeah.
right? So your factor model is slightly
Yes,
higher,
yes, sir.
very
Yeah.
little, by a very small amount. Got it?
Yes, sir.
Right? You can actually copy paste and put them into
Yeah.
your Excel sheets. You can generate the ROC and paste it over here
Okay.
and see what it looks like.
Okay.
Right? So 0.805 and 0.798. So
Yeah.
almost the same, but your factored model is slightly better. Got it? All right. All right. So Malik, be a little careful when you're doing this. Yeah, Siddharth, you have a question?
Yes, Karan. Karan, how can we generate the ROC curve and the area under the curve for a validation data set in SAS?
In SAS, there is a code to do it. There's a proc SQL code to do it. Remind me to mail it across. I'm sorry, I forgot to send it across. Right? So there is actually a
Okay.
proc SQL code. How it actually calculates is, I'll just open the whiteboard. No, there is a method. So have you heard of a method called the trapezoid method?
No, I haven't.
Right, so it's a mathematical method of
No,
finding
sir.
out the area of any quadrilateral. Right. So typically, you know
Okay.
what your ROCs are looking like. Right. Supposing this is sensitivity, this is specificity, right? And this is the diagonal line,
Random.
right? And I want to generate the area under the curve like this, right? So typically we are talking about this whole area. right? So Siddharth,
Yes, Karan.
right? When we're talking about area under the curve, we're talking about this full area, all right? So this is the full area that we are
Yeah.
talking about. So this is the area under the curve that we need to figure out, right? We already know that this area is about 0.5, which is under the line. Just what is this part over the line that we want to figure out, right? Right. So how the trapezoid method works is,
Yeah.
right? So it takes up one of this point like this, right? So can I say that this point over
Yeah.
here is like this and it is like this point, right?
Yeah.
Right. Then I have
Yeah.
another triangle which goes something like this, right?
Yeah.
Then I have
Yeah.
another triangle which goes like this,
Mm-hmm.
right? So I have multiple triangles going like this, so I can keep calculating the area of these triangles, right? And integrate them over. So this becomes the trapezoid method, right? So I have these multiple triangles. What I do is I simply join these edges together. So I can join this edge with this edge, right? I can join this edge with this
Yeah.
edge, right? So at the end of the day, what
Yeah.
I will have is instead of a curve, right? I will have what is a simply something like a quadrilateral with large number of edges. It will go like this, then it will go like this, then it will go like this, then it will go like this. So it will have edges over here. All right,
Yeah.
I'll try to make it a little better.
Yeah.
So it will go something like this, then something like this, then something like this, right? And this is my random line over here. So okay, I can always calculate the area of a quadrilateral, right? Right,
Yeah.
Siddharth?
Yeah.
So typically with this is how the area under the curve is being calculated, and there is a code in SAS which I'll forward to you that will implement this trapezoidal formula
Okay.
and calculate the area under the curve. All right.
Yeah.
So we can calculate the area under the curve for validation data set as
Yeah.
well. Okay. All right.
Yes, sir.
Now, so I see only Siddharth. Sorry, Siddharth. Only Malik has done the exercise. So I'm assuming Siddharth, you don't have any problems. But when you do it and try it, if you have any problems, you'll just have to mail it across to me. All right.
Okay. I'll do that. Yeah.
Right. So try it out. We'll move on to the next topic, which is your cluster analysis. All right. So
Okay.
can somebody explain what is cluster analysis? Anybody?
I guess it's you know breaking the population down into clusters with similar their demographic factors, or just grouping them on basis of.
Yeah. So it is also known as a subjective segmentation technique, right? So this is known as subjective segmentation. I am going to segment the for the observation into what kind of groups? Yeah, you were right, Siddharth. So could you elaborate a little more?
you know uh, it can be anything like similar demographic factors or psychographic factors, just grouping them on a basis of certain similarities.
Similar behavior.
All right. So let's get a few definitions in, right? First of all, it's a segmenting technique, segmentation technique, right? So this is segmentation of the data set, right?
Okay.
All right. And this is segmenting the data set based on what? So how are we segmenting this data set? Yes, Siddharth?
So typically, I think
How do you segment a data set? Based on what?
suppose take
The
the demographic state.
So it is based on the variables. Alright, so we are segmenting based on variables, right? For example, I've got two variables, age and height, right? Let's say I've got age over
Okay.
here, right? And I've got height over the y-axis, right? So can I represent my whole data set as a scatter diagram on the xy plane, Siddharth?
Yes, Karan, we can.
Right? So supposing, I generate this scatter diagram, it comes out something like this. Right? Then I've got some observations over here, right? And then some observations which are something like this over here, right? So now every observation has got a height and a weight, right? So typically how I represent is that this becomes the age and this is the height of that particular axis observation. Let's say the age is x and height is y, right? Then this point with the coordinates xy is plotted on the diagram or the scatter diagram, right, Siddharth? Right, Malik?
Yes, sir.
Right? So let's say age could be, 15 years and height could be like, 120 centimeters, right? And I have now plotted it on the XY diagram. Similarly, I plotted all the other observations that I have in my data set. Now, what is the objective of clustering? Right?
To group these kind of points which are very close to each other.
Group similar observations,
The dots in the graph
right?
here.
So the objective is, right? The objective is to group similar observations in the same cluster.
Here.
Second is group dissimilar observations in separate clusters. All right, all right. This can also be summed up in
Yep.
the sentence, right? Homogeneity within clusters and heterogeneity between clusters. All right. What does this statement mean? So Malik, what does this statement mean? When I say homogeneity within
That
clusters
is similarity within the
and heterogeneity
that
between
is
clusters,
similarity within the group.
right? That means observations in the same cluster should be
That is
similar to each other,
yes,
right? And observations in different clusters should be
and
different with each other, right?
yeah,
Right? So Siddharth, I need to divide all of these
yeah,
observations into buckets such that observations in the same bucket are similar to each other and observations in the different buckets are dissimilar to each other.
Yeah.
Got it? Right?
Yep.
So typically I can
Yep.
say, this is one underlying cluster in the data set. This is another cluster in the data set. This is the third cluster in the data set, and this might be the fourth underlying cluster in the data set. Right? So all of these clusters are separate from
Yes.
each other, right? They are very different from each other, but within the cluster, the observations are similar, right?
Yep.
Right? And how do you
Yep.
define whether an observation is similar or whether the observation is different from each other? How do I say that? Let's say I've got
Uh,
observation A over here, I've got, let's say, observation B over here, and I've got, say, observation C over here, right?
yes.
Got it, Siddharth? So Malik, my question is,
Yes.
which pair of these observations are most
okay.
similar to each other?
A and B.
Why A and B? Why not A and C or B and C?
Suppose for any like, marginal increment in x-axis, it is in parallel with the marginal increment in the y-axis also, in the case of A and B.
What you are doing is, for example, I'll give you an option, right? These three sets of observations, A, B, and C, right? In A, the height is, let's say, I give height equal to 120 centimeters, and let's say, you know, instead of age, I'm giving weight over here, right? So I'm plotting, Malik, so I'm plotting instead of age, I'm plotting the weight of the individuals over here,
Okay.
right? So weight is, let's say, 40 kgs, right? Now for B, let's
Okay.
say height is again 130 centimeters, and weight is, let's say,
Okay.
45 kgs,
Yeah.
right? Now for C,
Yeah.
height is 125 centimeters, and let's say weight is
Okay.
60 kg,
Okay. Yeah.
right? So if I have these three observations, right, how do I figure out which observation is the closest to each other, which pair is
Yeah.
closest to each other, Malik? Right? So what we do is we plot them
Like
on
we can
the
have
XY,
the
so
ratios.
not ratios, right? What we do is we plot them on the XY graph, let's say weight is one axis, height is one axis, and then we simply take the distance between the
Okay.
observations, right? So I take this distance between the observations,
Okay.
right? And the distance between the smallest pair, the smallest distance between the pair is used to figure out which observations are closer to each other and which observations are further from each other, right?
Yeah.
So Siddharth, the closer two points are each other in the plane or in the dimensional space, the more similar are those observations considered to be. Got it?
Yes. Yes.
All right. So Siddharth, I have a question.
Yeah. Current.
Yeah.
Yeah, go ahead, Malik.
Yeah. Here, like our metric is the distance between the variables, right?
Distance between observations, not variables.
Sorry, observation. So, if that is convert, what will be that distance in statistical terms, statistical parameters?
Correct. So I'm coming to that. How do you calculate distance between observations? Is that what you're asking?
Yes, yes. And also co- correlation with the statistical parameters that we came across.
Yes.
Yeah.
Let's say I've got 2 points
Same
A and
yeah,
B,
yeah,
right? How do I calculate the distance between A and
yeah,
B?
yeah,
Right? Let's say the coordinates
yeah.
of A and B are x1 and y1. B is x2 and y2. Right?
Okay.
Right, Siddharth, Malik, got it? Right?
Yes, sir.
Now the question
Yeah.
arises, how do I take the distance between A and B, right?
Yeah.
Alright? So let's say if I
We
plot
generally
this
have the
particular
distance
point,
from
right? So let's say
yeah.
Siddharth, I plot this particular point, right? So this
Yeah.
is x1 and this is the value y1,
Yeah.
right?
Yeah.
Similarly, this is x2 over here and this is y2 over here. So let me just make that clear,
Yeah.
right? So if I write it over here, so this is x1 over here, this is x2 on the graph, this is y1 over here, and this is y2 on the graph, right?
Yeah.
Right? So now can I say that the distance between A and B is actually the hypotenuse of this right angle triangle?
Yeah. Okay.
Right? Right, Siddharth? So this, sorry. So,
Yes.
so Siddharth, this is the hypotenuse, right? This is the base, this is the perpendicular,
Yeah.
right? So what is
Yeah.
hypotenuse equal to?
H square is equal to B square plus B square.
Right? Which formula are we applying over here?
Hypotenuse theorem.
Pythagoras.
We are applying the Pythagoras
Oh,
theorem,
sorry. Yeah. Pythagoras theorem.
right? So I'm not going to
Yeah.
ask you to derive the Pythagoras theorem over here, but you can do it using trigonometry as well, right? So I
Yeah.
know that H, right? That H is equal to P square plus B square under the root, right, Siddharth?
Yes, Karan.
Right? So can I say P is simply this distance,
Yep.
right?
Y2 minus
And
Y1.
base is this distance, right? So
X2
this is base,
Yeah.
and this is the perpendicular. So what is perpendicular equal to? Enter in the formula, what is perpendicular equal to now? This is y2 minus y1, right?
Y minus.
Right? So
Yeah.
I can write y2 minus y1 whole square plus, what
X2
is b?
minus X in the
B is x2 minus x1 whole square under the root, right? So if I've got 2 points x1, y1 and x2, y2, what is the distance between the 2 points?
Y2 minus Y1 plus X2 minus X1 the whole square.
No,
Oh, sorry,
y2
square
minus
of both
y1
and
separately
the
whole
under.
squared. So y2 minus 1 separately whole squared plus x2 minus x1 separately whole squared and then the under root. Got it?
Yeah. Yeah.
Right? Not the whole square because that will be wrong. Right? So it is y2 minus y1 the whole square plus x2 minus x1 the whole square and then I take the full under root. Right? So is everybody clear how the distance
Yeah.
formula is being calculated?
Yes.
Yes, sir.
Right? So this is how we calculate the distance between points. Therefore, I can now start calculating the distance between any two points and based on the distances between the points, classify points which are close to each other into the same cluster. Right, Siddharth?
Yes.
Yeah.
Right? And classify observations which
Yes,
are
Karan.
which are very far from each other into different clusters then. So the closer the 2 points are, they get classified into the same cluster. The further away 2 points are, they get classified into separate clusters. Alright? So is the basis of clustering
Yeah.
clear? Right? So what kind of variables can be used for clustering?
Continuous variable.
So Malik, why only continuous variables?
I think in the rest of the cases, I think the distance is fixed, like categorical or ordinal equal distance.
So Malik, I am using
On observation.
Malik,
Yeah.
Malik, I am using addition, subtraction, and multiplication, division in the formula over here, right?
Yeah.
Right. So Malik, this involves
Yes.
subtraction and then multiplication, right?
Yeah.
So what kind
Exactly.
of variables can I do subtraction, addition, multiplication, division on?
Continuous.
Right? Can I? So if I have a categoric variable like let's say I've got age, then I've got height, and then I've got let's say something like the shirt color, right? So
Okay.
can I plot shirt color on an axis?
No.
I can plot age and height, but I can't plot red and green because then the formula will become somewhere red minus green whole square, right?
Or,
Plus,
this,
the delta of age whole square plus the delta of height whole square, right, under the root. But I can't do this. This will create problems for
yeah,
me, right? So that is why,
yes,
what kind of variables can be used?
continuous, that is ratio variables.
Right? Only continuous ratio variables should be used, right? So typically it is similar to like factor analysis. Factor analysis is also restricted to, right, your continuous variables. So answer is again ratio.
Ratio. Even interval also not, right?
Even
They won't
interval
have
we
the,
try to
they will be having
avoid.
arbitrary.
You can use, but we try to avoid that, right?
Okay.
So you're right. Ratio interval variables can be used, right? So I'll write ratio interval continuous variables only, right? Which can be plotted on an axis. All right. So I have a question now. Let's say
Yeah.
supposing this is the scatter diagram that I have, right, in my data set, right? So how many naturally occurring clusters are there in this data set, Malik?
3 correct.
3, right? Now to find out the distance between
Yeah.
the observations, let's say I have, let's say 100 observations over here in my data set, right? To do clustering, I need to calculate the distance
Yeah.
between every observation,
Yes.
right? So I will calculate the distance between every observation
Yeah.
with every other observation and then classify the one closest to each other into the same cluster, and different observations
Yes.
observations which are very far away from into different clusters, right?
Yes.
Right? So Malik, if I have 100 observations, how many distances will I calculate?
Okay.
So how many pairs are there?
100 into 99. 100 into 99.
100 into
99.
that's it. It will be NC2, right? Right?
By 2
By
divided
2,
by 2.
right? For example, let's say I've got 1, 2, 3, 4, 5 observations like this. So how many pairs are possible?
Yeah, it's selection of any two distinct points, that is NC2.
Right? Supposing I've just got 4 pairs, right?
Yeah.
So I'll make it easier.
Mm.
I've got 4 points. Right? Right? So Malik, I've got 4 points. 1, 2, 3, 4. So how many possible pairs are there? So this is one pair,
Six.
second pair, third pair,
Yeah.
fourth pair,
Yeah.
fifth pair, sixth pair,
Yeah.
right? 4 points give me 6 pairs,
Yeah.
right? How many pairs
Yeah.
will 5 points give you? So I've got 1, 2,
10.
3, 4, 5, 6, 7, right? Then I've got 8,
Yeah.
9, and 10,
Yeah.
right?
Yeah.
Now any other pair, right? So 5 is
No.
giving me 10. So what is the formula? It is always n into n minus
N
1
into n minus 1 by 2.
by 2, right? Where n is the number of observations,
Right.
right? So if I've got 100 observations, I need to calculate NC2 or n into n minus 1 divided by 2 pairs, right? Right, Malik? Now supposing you want
Yeah.
to segment the customer database of a bank,
Yes, correct.
right? So I want to segment the customer database of a bank. So a bank will have how many subscribers or customers?
Mm-hmm. Some lakhs like that.
How many lakhs? Siddharth, give me an example.
Mhm.
How big will be
Yeah.
the customer database of a bank?
Customer, it can be any figure, it can be 100 lakhs, 10 lakhs.
For example, take SBI, it's dots around 50% of Indian population.
Can I say, let's say 1 million observations,
Yeah.
Yeah.
right? I want to segment
Yes.
1 million observations. So this is, let's say, 10 to the power 6,
Yeah.
right?
Yep.
Right. So Siddharth, how many pairs will I now create?
1 million into 1 million minus 1 by 2.
Can I say it is 1 million into 1 million itself,
Yeah.
Yep.
right?
By two.
Divided by 2. So this becomes, let's say, 0.5
10 to 9.
into 10 to the power 12,
So 1 million. That is 1 billion.
right, Siddharth? So can I just say this is approximately equal to 10 to the power 12
Yep.
only, right? So it's 10 to the power 11 or 10 to the power 12, which is a very big number, Siddharth, right? So how long will a computer take
Yeah.
to calculate 10 to the power 12 distances?
I will take a look.
So how long will this take to a normal computer? How long will this take?
I think 5 to 6 seconds.
5, 6, 7 seconds, is it? A few seconds?
Yeah.
Okay, so tell me,
Yeah.
Siddharth, a normal, computer, let's say a normal PC or a laptop that you have, in 1 second, how many pairs will that laptop be able to calculate?
How many pairs?
So tell me,
1/6 of this.
in 1 second, how many
Yeah.
pairs will this? So typically, how many operations can a laptop or a computer perform in 1 second?
That is
Megaflop, teraflop, petaflop, right?
that is limited to
Right?
yeah.
Supercomputers operate in megaflops and
Limited to
teraflops, right?
processors.
So how many calculations will
Yeah.
a computer do in 1 second? Malik, how much? How much? 100,000 pairs, 10,000 pairs, 1 million pairs, 1 million
Yeah.
distances, right?
That is
Each distance requires,
instructions per second are
right? So Siddharth, each instruction requires squaring the distance and then taking the square root,
Yeah.
right? So every
Yes.
pair, every time I calculate the distance between, let's say, pair A and B, I need to first square two distances, square the delta x, square the delta y, add it up, and then take the under root, right? So I have to perform,
Yes.
right, one, two, three addition operations,
5
two
operations.
two multiplication
Yeah.
operations, that is
Yes.
squaring, and one under root operation,
Yeah.
Yeah.
right? So
Yes.
3, 4, 5, 6 operations for each pair, right? So let's say that every pair is equivalent to one operation itself. So we'll keep it as one operation. We'll just ignore this. So how many operations can a computer perform in 1 second?
Okay.
Give a figure, right? Let's say
Uh,
your computer is,
10
let's say,
operations.
1.5 gigahertz, right? Right? Right, Siddharth?
Yeah.
Right? 1.5 gigahertz, 2 gigahertz computers are normal, right? How much is a giga?
Yes.
Yeah.
How much is a giga? 10 to the power 9, right?
It is 1024.
Right?
Yeah.
Mega is, 10 to the power 3. So giga is 10 to the power 6.
Yeah. Yeah.
right?
10 to the power
10 to the power 6. So let's say it can do 10 to the power 6 calculations a second, right? Even though in actuality it will be more than that because there are 5-6 operations per distance, but we'll assume in 1 second it can calculate 10 to the power 6 distances. All right?
Yeah.
Right? So how many seconds will it take to calculate 10 to the power 12 distances?
10 to
10 to
the
the
power
power
6.
12.
Yeah,
10 to the power 6 seconds.
divided by 10 to the power 6. These many seconds, right?
Yeah.
Time for
That is 10 power 6
10 to the
seconds.
power 12 calculations is equal to 10 to the power 12 divided by 10 to the power 6. Right, Siddharth?
Yep.
If
Yes, Karan.
अगर 1 सेकंड में 10 to the power 6 करता है, let's say for example in 1 second can do 10 to the power 6 calculations, right? To calculate 10 to the power 12 distances, it will take 10 to the power 12 divided by 10 to the power 6, right? How much is this, Malik? How many seconds?
10 to the power 6.
10 to the power 6 seconds,
10
right?
to the power
Yep.
6 seconds.
How many minutes is this? 10 to the power 6 divided by 60 minutes, right? We assume this becomes equal to, let's say, 10 to the power 5 minutes, right? Assuming that 100 minutes make 100 seconds make 1 hour. To make our calculation easier, right? We'll take this as to be equal to 10 to the power 5 minutes. How many hours is this?
Divide by 60. Okay.
Sorry, 10 to the power 6, if I divide by 100, it becomes 10 to the power 4 minutes, right? So it becomes 10 to the power 4 minutes. And I divide by 100 again to get the hours, so it becomes 10 to the power 2 hours. So how many hours is that?
100.
100 hours. 100 hours plus, Siddharth. So it will not take a few seconds, right? It will take anywhere from 100 to, let's say, 400 hours, even if we have a 1:4 ratio somewhere, to calculate the distances between just 1 million data set, right? So this is talking about, let's say, more than
Yeah.
4 days of calculation.
Yes.
Right, Siddharth? Right, Malik?
Yes, Karan.
So, Malik, do you understand how difficult it is to calculate the distance between every possible point in the data set?
Yeah, it seems it requires a lot of computing power.
Right? So, it will require a lot of computing power. So, that's why we don't use this approach. We use something known as a heuristic approach. What is a heuristic approach?
Yeah.
Right? A heuristic approach is a shortcut approach.
Basically, heuristic means, yeah.
A shortcut, right? So, we won't calculate every possible, we'll only calculate a few. Alright, so I'll just delete this off. Right? Amongst the heuristic approach, one of the most commonly used approaches for clustering is known as the K-means clustering. Right? Siddharth, have you heard of this term, K-means cluster?
No, I haven't.
Right? K-means. Malik, have you heard of this K-means clustering?
Yeah.
How does this work?
No current.
Alright. So the K stands for how many clusters do I want to calculate. So when I want to do K-means clustering, I have to first give the value of K equal to some number. Right? So in this data set, Siddharth, how many clusters do you want to create? Yeah, Siddharth, how many clusters do you want to create in this data set? Hello?
8.
Yeah, Siddharth.
10 clusters.
How many? How many clusters do you want to create in this data
10
set?
clusters.
8 or 9 clusters? Why 8 or 9, right? Siddharth, I see 3 naturally occurring clusters. Why not 3 clusters?
Oh, I was looking to the other data set. Yeah, 3 clusters.
Right? Supposing I want to create 3 clusters, what it will do is, it will, right, randomly assign 3 cluster centroids in the data set somewhere like this. Alright? Right? So
Okay.
these points are called the centroids. Right? In the next step, what it will do is it will calculate the distance of every observation with these centroids. Right? So I calculate the distance of every observation with these centroids. So if I have n observations, how many calculations am I doing?
Yeah.
Yeah, Siddharth, how many
N into
observations am I
3.
doing? How many calculations am I doing? When I calculate the distance of every observation with these 3 centroids, so how many observations or how many
Okay.
calculations am I doing?
There'll be n into number of points. A into n.
Will it be 3n calculations, Siddharth?
3 and
Where k equal to 3?
oh yeah. Yeah.
Or can I say
Yeah.
kn, kn calculations? In this particular case, if I'm working with 10 to the power 6 observations and I want to create 3 segments, then how many calculations is that?
K into 10 to the power.
So it becomes 3 into 10 to the power 6 calculations.
Yes.
Right? So after this, what will I do now? Once I've done these calculations, what's the next step?
Next step is
I assign every
we
observation.
have the points which have the minimum distance.
Yeah. So now I assign every observation to the centroid which is closest to it. Right? So all of these observations get assigned to this centroid. Right? All of these observations and a few of these observations get attached to this centroid. And all of these observations get attached to this centroid.
Yes.
Right? And I have my solution at hand. Right? Right, Siddharth?
Yes.
Right?
Yes,
So
correct.
this is known as the first iteration. But is this the best possible clustering solution? Or can I make it better?
We can go more steps.
So how do I do that?
Different centroid points.
Right? How do I get the second set of centroid points? Can I, for all of this cluster, calculate the average?
Should be a little.
Right? Can I calculate the next centroid as the average of these observations?
Yes.
Right? So instead of centroid being here, where will it go next? The next centroid
Somewhere in the middle.
will move somewhere over here. Right?
Yes.
It will move somewhere over here. This centroid will move over, it will go over here. And this centroid, instead of being here, it will move a little towards this point. Yeah?
Yes.
Right? Then what I do is I remove the previous cluster classification. I actually delete it. I don't need it anymore. Then I recalculate the distance of every observation with these new centroids now. I disregard everything. I repeat this whole process once more. Alright, Malik?
Okay.
Malik, got it?
Yes, sir.
I repeat it once more.
Yeah.
Right? Then I reclassify every observation again to the centroid closest to it. Now what will happen is this particular observation which was going into this cluster will now start going into this cluster. Right? So this observation is actually closer to this centroid. Right, Siddharth? Because this centroid has become closer and this centroid has actually gone further away. So this point gets classified over here. Right, Siddharth?
Good.
Right? So my new cluster definition will come something like this. This has becomes one cluster, this becomes the second cluster, this becomes the third cluster. Right? And how many calculations will this take?
Right. Same, K into N.
First iteration, second iteration will take again 3 into 10 to the power 6. Right? After this I can do a third iteration, a fourth iteration and a fifth iteration. Right? Till the time after a certain while I'll
Yes.
see that my centroids stop moving. They'll reach the center of the clusters, right?
Yes. Yes.
Right? So typically after, let's say 8 to 10 iterations, right, centroids stop moving. So typically we do about 10 iterations in this, right? So if I do 10 iterations, the total number of calculations is 10 into 3 into 10 to the power 6,
Then this,
right?
yes.
So this becomes 3 into 10 to the power 7 calculations.
3 into 10 is first.
And if in 1 second I do 10 to the power 6 calculations, so this will take 3 into 10 seconds. It will take about 30 seconds to do the clustering.
Yes.
Right, Malik? Yeah,
Yes,
Malik,
sir.
got it?
Yes.
So if I do it
Yes,
the
sir, I
full
got it.
way, it will take me about
Hmm. 4 days.
4 to 8 days to do this clustering exercise if I do it with every observation and distance. And if I do it using KMeans, it will take me 30 seconds.
Yeah.
Right? So,
Karan, I have a doubt here.
yeah. Go ahead.
Yeah, we have identified centroids, right, at the first iteration.
Yeah, the centroids are identified randomly within the data distribution. So the centroids are not going to be identified, x1, x2 and x3 over here. Then majority of your data is over here.
Okay.
Right? So the centroids are identified
Yeah.
where the majority of the data is lying. Right? So
Okay,
looking
that
at
is a random selection, right?
yeah, so looking at the observations, we randomly select a few points and make them the centroid,
Okay.
or looking at the variable distributions, right? So knowing that where is the maximum minimum of each variable, I know that maximum of this variable lies here, minimum lies here, minimum for this variable lies here, maximum lies over here. So this automatically gives me a square within which most of my observations lie, right? So I randomly pick up some
Okay.
points within the square and make them as the centroids. Alright? The only disadvantage is that I have to specify this value of k. Before I even do the clustering, I need to specify how many clusters to create.
Even that is also
Right? So we need
what
to
could be
specify
the
beforehand.
Yeah. What could be the assumptions for specifying particular number of k?
Yeah, typically that is how many clusters we want.
What could be the basic?
Right? Typically we are always generating between 3 to let's say 7 clusters. Right? We rarely go more than 7 clusters, and below 3 there's no point. We might as well do high medium if I'm doing two observations or 2 clusters. Right? So typically the minimum number of clusters we extract is 3, and maximum 4, 5. In the extreme cases we can go up to 7 clusters. Right? So it depends on like factor analysis. Number of factors is dependent on you, so number of clusters is also dependent on you itself. Alright? So what's the minimum number of clusters we can go for?
Okay.
Siddharth, what's the minimum number
3.
of clusters? Theoretical minimum.
1.
Theoretical minimum is 1. All observations in one supercluster.
Yeah.
Right? What's the max number of clusters?
The number of data points.
Equal to n, where n is equal to number of observation. Every observation, or n is the number of unique observations. Right? Where every observation becomes a cluster of its own.
Yes.
Right? So the number of clusters can vary theoretically between 1 to n, but typically we vary between 3 to 7. Okay. Alright, so this was how we do K-means clustering. Right. Now what I'm going to do is I'm going to demonstrate this on SAS. Right. So my
Okay.
SAS code may not work right now. So what we'll do is since the others are also not here, I think we'll stop the class short now and continue with this tomorrow's session so that everybody is here. Right. But what I want you to do is I want you to run this particular code. So I'm writing down the code over here. Right. The code will be Proc fastclus. Right. Proc fastclus. Data equal to dataset name. Right. I'm still not clear of the right.
You can put it in the chart window, Karan.
Yeah, just let me try it out here. So max clusters equal to x, where x is the number of clusters you want to extract or is the number of k. Out equal to dataset name, where you want to specify the clusters. After that, give the semicolon. Then give the ID variable. Right. So give ID as the ID var. So which is your serial number variable. Then give var v1, v2 till vn and run. Right, I'll just put the code into the chart window. Right, so proc fastclus data equal to, let's say, dataset name, max clusters equal to, let's say, x, out equal to out data name, ID equal to serial number, var v1, v2 vn, run. Right. So what I want you to do is I want you to try out this proc fastclus code only on the telecom dataset independent variables. And needless to say, avoid the categoric variables in this data set. Right? Avoid all the categorical variables in this data set. It makes no sense to do it on categoric variables. So just like factor was done on the continuous variables, do this also on the continuous variables. And open the output data set and scroll to the extreme right hand side. You will see all observations get classified. Give x equal to 3 or 4 or 5. Right, and compare the result. All right, Siddharth, you will be able to try this exercise out.
Yeah, Karan.
Right. So what I'll do in tomorrow's class is I'll start with the proc fastclus output in SAS itself. Right. One is doing this. In the next class, I will discuss the output. How do we interpret proc fastclus? Got it? Right, and proc fastclus is nothing but KMeans. Right, so fastclus, sorry, right, so fastclus is your KMeans procedure in SAS. Okay, so before we sign off, Siddharth, now are you clear what does KMeans clustering mean?
Yes, I'm clear.
Yes, Siddharth, you are getting completely it's coming. I can't hear you. Can you try it again? Hello.
Yeah, Karan. I'm clear about this.
All right. So KMeans methodology. You understand?
Yes, Karan.
Right?
I'm clear about this.
Right. Malik, are you also clear?
Yes.
Yes, Karan.
Alright, so in tomorrow's class when everybody is else there, I'll do a quick recap. So tomorrow's class I'll ask you to explain K-means clustering, alright? Right, Malik?
Yeah,
Sure.
sure.
Okay, right? Proc fastclus
Yeah,
output, then I will explain tomorrow's class again. Okay, so Siddharth, try and send me the exercise also. The factor logistic exercise, Siddharth.
Yeah, I'll send it to you by tomorrow.
Alright, try and send it to me by tomorrow, the Charles Book Club. Alright? Okay, and tell me on the credit case study, can we do the can factor analysis be done on the credit case study at all?
No, as of now.
Yeah.
Yes, no.
No.
We can do it, but there are a lot of categorical variables in that.
Right, there are only 3 continuous variables, so we cannot do it.
Yeah.
Alright, so it makes no sense to do factoring on all the categoric variables. That will be an incorrect use of factor analysis. Alright?
Yeah.
Okay, so let's reconvene tomorrow same time.
Current.
Yeah, Malik, go.
Yeah, I have a question. Last question.
Yeah, go ahead, go ahead.
Yeah. See here, like we are considering like mean or distance is a criteria. Suppose take two variables, that is height and weight, as we took in the example.
Yeah.
So is it required to have the same unit or same scale of the variables that we are?
Yes, so that is what I will cover tomorrow. So we need to standardize variables as well.
Yeah.
Right, so that is known as variable standardization.
I guess.
So that we still haven't covered yet.
Yeah.
You're right, because we are using the variance between the variables, right? Right? In some variables, the let's say age is in years, but height is in centimeters.
Yeah.
Right? So obviously centimeters will contribute more to the distance. Yeah,
Exactly.
so distance gets biased by centimeters. If I change the height from centimeters to meters, right, then suddenly the impact of height is removed from the distance formula.
Yes, exactly.
Right, so we always standardize variables. So that is what we will cover tomorrow. All right.
Okay.
All right.
Yeah.
All right, guys. See you tomorrow.
Tomorrow I may not be available.